So, hi everyone, my name is Oak, I'm from Topology. Quick show of hands, who already watched this talk from the past couple of days? Okay, not as many as I thought, so it's fine. We can repeat some things here. So, we are going to have a live demo. We are crossing fingers that it works. For the ones that already saw the live demo before, it's going to be different. We removed the walls for it to be easier for you to jump to the front. So you can just pop up your laptops if you have there. You can join the network there, and later on we are going to hop in our awesome live demo. So today we are talking here about CRDTs. The main focus of this talk is going to be gaming focused. For the people that saw this talk in Common Web, is going to be pretty similar. The ones that saw it yesterday, it was more focused on application side. And basically, we are starting with explaining CRDTs. Any one of you know about CRDTs? Lots of stuff? It is more or less, you know perfectly. Oh, now you are going to correct me. So basically, CRDTs are based on this paper. It's two authors from Portugal, two authors from France. And basically, they stand for conflict-free replicated data types. And the too long DR of that paper is, I have my local data, I can update it as long as I want, and eventually I can ensure that I'm going to reach the same state as other peers on the network, on other computers. And the thing about that is we don't need consensus for that. Because the way that we define when we have problems with the conflict is we have predetermined rules to fix that. And the most simple examples that we have are the two first ones, the grow-only counters and the positive-negative counters. Basically, grow-only counters are counters that you can just increment those. So all the CRDT data types are monotonic, so they can only increment in size. And the thing is, grow-only counters is you are incrementing your own counter, and you know for sure for the whole network that at least your counter is going to be the minimum value. So when you are synchronizing with the other person, you know that their value is not going to be smaller. If it's smaller, while you are merging, you know that your value is the right one. And positive-negative counters, you don't know the absolute value of the network, but you know for sure that the positive-negative counters are two grow-only counters, one for positive values, one for negative values, and you subtract the negative by the positive. So you know also that for each one of those counters, you know that your local value is going to be at least the maximum value of that, and you can subtract it from there. And the nice thing about positive and negative counters is that you already saw some composability between CRDTs. And JSON CRDTs are a way more complex data type that exists, but then you can start moving around with JSON objects. The thing is, they are also composed by lots of smaller data types that are CRDTs. We started doing some experiments in the past. Here is a game that we did in the past. GG is jumping around there. We had collisions here. This was all made with CRDTs, with a specific CRDT library that is YGS. Anyone knows about it? So the guys from CRDTs don't know this. This is pretty big. And we also implemented the WebRTC part, and the whole game was built with Phaser. We posted about it. We had some good feedback from some relevant people. And then we decided that we wanted to move forward instead of using YGS to use CRDTs. And we want to actually create a new type of protocol, which is conflict-free replicated, based on conflict-free replicated objects. So those constructs that we were talking about, that we have CRDTs, we can compose them. Yeah, we want to do that, but in a small talk, like objects. So basically, we want to have those kinds of objects, but those objects right now are not that easy to construct. And the thing is, for that, we need to have some blueprints to have those objects across the network. We need to have some interfaces for us to know what to call on within the objects. We also are trying to and plan on implementing signaling, which is basically from one object you can signal other objects to update their states in some way. And for that we need mutator functions, we need view functions, and merge functions. Merge, it's super standard on CRDTs usually, so it's just the default one. Views are read-only functions, and the mutator functions are a super special case because, like all CRDTs, they are monotonic, so they can only grow size. Grow size in the sense that the state needs to be incremental. And basically this is lots of the stuff that we are worried about for the CROs. So basically we need to care about the peer-to-peer messaging. Currently we are delegating all of that to P2P from protocol labs. We need to have causal consistency for the operations that we are bringing. We need to have some type of causal ordering between those operations. Then we have clocks. Then clocks consensus is going to depend on those types of clocks, which is basically you can't have timestamps on distributed systems. It's something that we would love, but we don't have it. And because of the state is grow only, we also want to actually do some compaction of the state from time to time. And this is super awesome, but actually the live objects don't persist on the network. So if all the peers that we have on the network just turn off, yeah, that object is going to the network. And because of that, we are also thinking about snapshotting in some other kind of distributed system like blockchains, IPFS, you name it. Basically, the whole structure for this is the super sketch that Gigi made out of the paper. This is the sketch of the network, and basically, in the cores there we have the live objects on the network, the CROs, and what is super awesome about this is we have Alice, Bob, and Charlie with the blue object, and the thing is, no one needs to care about it. So those objects are going to live just on those three nodes, and when they are communicating updates and all of that, they are just communicating between themselves. This is a pub subgroup. So it's super awesome because the rest of the network is not going to be overloaded by messages that they are not interested in. And usually everyone asks, so what can I do with that? And then we have lots of use cases. So collaborative tools is something that, let's wait a bit. Can you still hear me? Or no? Yeah, then I'll keep going. So collaborative tools is something that is been used, in the wild for a long time for CRDTs. So you can think about it as like Google Docs. Google Docs actually implemented a long time ago another type of technology which is OT, but nowadays they are using OT and CRDTs to do that. The local first community is super hyped about CRDTs and all of that. A part of that, we have also the social networks and applications. We have the example of Farcaster. Farcaster has a big CRDT to manage all the posts and all that. And our main use cases in this talk, and also for topology, because we also drive all of our examples there, is the games and autonomous worlds. And for that, we already did the previous example with the penguin, and we prepared another demo. And this is the time that we are going to see if everything is going to work. Let's cross fingers.
If anyone has laptops, get it up. We have a fun live demo that we can try.
We can try, no promises.
Wi-Fi password should be passed around. If anyone needs Wi-Fi password, let me know.
Huh?
Does anyone need Wi-Fi password?
Oh! So, there's someone there. We have one person there. Success. 2. So, before going to the front and explain a bit the demo that we have here, basically, what we have here now, it's presence. And basically, we are all in the peer-to-peer, in the same peer-to-peer network. Currently, we have a server somewhere that is just doing the handshake for the SDP, for the WebRTC. But after that handshake, we are actually all connected with each other. So currently, we have a peer-to-peer connection here. And here we have a pub subgroup for just the movements and say, oh, I'm here, and you can check the movements of the players. But That big thing there is actually already a CRO. So that's one of the first implementations that we have for CROs. You can go there, you can draw some stuff. I'm going there now to draw.
Yeah, let's go
So,
paint over it. You can click and paint.
you can so the sticker that is selected is one on the top left, but you can actually press C to change the sticker if you want. If you can't make it to the front, it's skill gap.
You can't make it to the top. You're just not good at jumping around.
Oh, skill gap, see? Yeah, so previous demos we had a wall. We had walls everywhere. And I made it to the front with the wall during the live demo.
And then if you go to the canvas, if you click it, you can paint stuff. And then these are all done on CRO, P2P connections.
So I'm just hoping that someone goes there and paints it. Because I can't, it seems.
Seems like we have about 6 people all connected, jumping around.
And no one can make to the front.
Well, I thought that.
It would be easier now.
Oh yeah, someone's up. Yeah.
Yeah, someone is already painting. So I'm going to paint this. Yeah. And this is my dog, my puppy.
You should paint italic.
Italic?
Italic.
You have italic. Someone put it italic on top of my dog. I don't like it. You are bad persons. Okay, so basically this is our demo. Basically this big canvas, it's a CRO. It's based on CRDTs. And yeah, but basically that's it. It worked. It's 3 out of 3. We have 100% success rate for EthCC.
Maybe you can fall down and then see from far away so we can have a better.
Sure thing. You can also go to the back and go to the jump pad. Yoo. How beautiful. Everyone painting on the canvas. So initially you were supposed to be able to paint on the top, but yeah, because of some constraints you are not. You are just going to be able to paint on the draw, until the draw line. We don't have platforms on the top in the future. Going back to the presentation. Of course, we had the backup plan, as always. And the thing is, why did we need a backup plan? Actually, we didn't, because the gods of the internet allowed EthCC to do all the demos, and it was super good, super nice. We even tried it with mobile hotspots, and it worked. Different hotspots. The thing is, exactly, it's super tricky actually to have connectivity between browsers. There are lots of firewalls when you are connecting with browsers in your local home network and all of that. If you are with your mobile, you can actually also try to do the Counter Splash with mobile. You don't have controls to move around, but you can actually see the canvas and see the peers jumping around and all of that. The thing is, exactly because of net traversals and firewalls, we need to do hole punching and we need to care about lots of other stuff, and lots of times it doesn't work. And one of the easiest solutions that you usually have there is relay servers, but in our case, relay servers are not efficient at all in the sense that they need to relay lots of messaging everywhere, and actually it's not feasible for these types of cases where you are moving lots of data between peers, and if you are doing relay for lots of peers, it doesn't scale at all. So that's something that it also doesn't work in our use case. The thing is, both of these stuff is actually fixable when you have public nodes. So if you have public nodes that are actually interested in staying in the network and they have a public connectivity, you can easily reach them and they can just broadcast the messages because they are in the same pub subgroup. A part of those problems, there are lots of problems also related with gaming. And basically, we have these three ones, which is teleportation, telekinesis, and speedx. Yeah, in the example that we had for the penguin worlds, you had a super nice feature, not a bug, which is when you are doing the collision, I would compute the collision on my local machine and say to the other guy, yo, back off this bit, and the guy would back off. No, just optimist. The guy was like, oh yeah, I'll just back off, no worries. So I can just fake messages and say, yo, back off, back off, back off, back off, and then the guy is on the other part of the planet. Teleportation it works exactly the same. I can just say, oh, I am actually not here, I'm actually there, and suddenly we have some teleportations. Speedx are always problems in every kinds of games that you might think of. And the thing is, actually those are solved within the first. Most of those are probably solved because there are problems that we are trying to work on. And these are problems that are actually all research topics within PhDs, and most of the professors in universities are currently researching those. And the thing is, the first one is the constraints within CRDTs. And if you define good enough constraints within those kinds of objects, you can actually try to avoid lots of issues like teleportation is one of those, telekinesis for sure is one of those. But apart of that, so the DDoS is something that came out actually from the Komorevi's house. A guy asked a question about DDoS and I was like, oh, actually that's a problem, I forgot to put it there. And actually that's a big problem in every peer-to-peer network that you might think of. Because peer-to-peer networks are totally permissionless. So anyone can just boot up a new node and they are in the peer-to-peer network now and they can just say whatever they want there. And if you are banned because of bad behavior there, yeah, I'll just spin up a new node. It's fine. A part of that, we have timing in the distributed systems, always problems. Compactions and hash graphs, we already defined those on the previous slide where we say that we have lots of things that we are thinking about for CROs. And because we are working in lots of hard problems in distributed systems, we are actually hiring also. So if you want to work, just ping us, we are going to be around. We have lots of open positions because we need to solve hard issues and develop everything. So even if you are not that interested in research, you can just help out developing most of the stuff and it's totally fine. And if you actually are not that interested in solving those kinds of problems, but want to hang out for the vibes, we also have lots of communication channels. So you can just join. The Telegram is super new. We created like 2 days ago. 2 days ago. The Discord has been around for a bit longer. On the GitHub, we have all of our work that we are doing is open source. So paper, specs, code, we have all of that open source. The specs currently is empty because we didn't do it yet. The paper is going through a big review right now. Next week or in 2 weeks, we are going to have it updated. We are going to communicate those in Discord and Telegram, so be there. And yeah, the code is totally there, all of that. And this is the QR code for the Discord, because the Discord link is ours. And that's it. Open for questions. Go ahead.
Do you, with the fact that you need a server for the RPC handshake to start with, that's effectively like bit-to-bit bootstrapping, right?
Yeah.
And so, like, is there always a requirement for some kind of startup server, or are there kind of potentially solutions in the future?
So the thing about us having the current server is just to have a bootstrap node that is public. Because in the future and right now, you actually don't need that at all. So if you know someone that is already in the network, you can just join the network if you can have a connection with that person. So the relay server that we currently have it's just for helping the WebRTC handshake for the SDP version. So for the SDP file descriptor to be exchanged, but you actually don't need that. If you have a connection with any other peer and you know about them, you can just use that peer to bootstrap the network. Yes?
So how are you handling that upstream thing? Is that handled by, is it libp2p that does that for you?
What? Sorry?
Handling the NAT traversal.
Yes. The net traversal. So net traversal is something that P2P has been working for a long time. Actually, they had some experiments with net hole punching. They did lots of stuff, and yes, we are handling within P2P. So it's not perfect yet. Even within P2P, it's not perfect, but it actually works out of the box pretty well. If you set up all the stand servers in the West version of P2P, you actually don't even need to set up the stand servers because they already provide some list of stand servers that are public, like Google, Cloudflare, and all those. But if you set up everything correctly, you get pretty good connections out of the box. And unless you are like Kono, that had a computer that went to China, and that computer can't connect to anything. Yeah.
It's like, it seems like most of the current like use cases work best for like collaborative software and cooperative situations.
Mm-hmm.
I know you kind of listed some of the hard problems there. Like, what are some of the requirements for working out like a hostile or competitive environment that can function?
Yeah, so that's exactly the thing about the R problems that we were talking about. So when you are thinking about competitive environments, invariance is the super straightforward one that you want to fix, and you also have the part of the causal dependencies on the operations. You want that one super fixed in the sense that if I just want to care about invariance and all of that for limiting the nodes and also to resolve conflicts when some operations have the same dependencies on the causality graph. When you have in the causal graph operations that are not in conflict with others, you don't care because you have a time approach there in the sense that you know that one operation is older than the other one. I guess that's it. Thank you so much.